What's up, scholars? All right, so we finished talking about the area and volume different shapes take up. Now we're going to move some shapes around and change them in some type of way. First, we're going to talk about rigid motion in a plane. Rigid meaning not changing, motion meaning moving, and in a plane on a flat surface. So we're not picking it up and like dropping it somewhere with like a crane situation. We're just moving it around on the flat surface. We've got a couple different ways to do that. We could have a transformation, which is a change in the size, location, or orientation of a figure. A change in the size, the location, or orientation of a figure. Size, that one's pretty obvious. We can make it bigger or smaller. Location, we can move it around on the flat surface, aka the paper. Or orientation, maybe we flip it around, maybe we flip it over itself. We just change totally where it is in space. That's transformation. And isometry is a type of transformation that preserves parallel lines, angles, and distances between the points. Preserved parallel lines, angle measures, and distances between points. That should be plural. So an isometry is a transformation that basically leads to the same shape. It's just somewhere else. We're not changing its size. Transformations that are isometries are sometimes called rigid motion. Rigid motion. Alright, well there's three types of rigid motion we're going to talk about today. We've got a reflection, which is a transformation which flips the figure over a line. Flips the figure, that's supposed to be a P, flips the figure over a line. Kind of like this dude. We took an F and we flipped it across this line. That line, of course, has a special name. It's called the line of reflection. Line with an I-N-E of reflection. Cool beans. You'll notice the reflection looks completely opposite of the original shape, which we call the pre-image. That's the pre-image. What do you think that one's called? Oh, you are correct. It's the post-image. Pre and post. Just like when you look in the mirror, you're actually seeing a flipped version of yourself. You're seeing a reflection. You look exactly opposite to the rest of the world as you do in the mirror. Cool stuff. Now, if you're interested, you should Google Abe Lincoln mirror reflection and see how totally different he looks. Kind of interesting. All right, another type of rigid motion we've got is a rotation, which is a transformation in which a figure is, what do you think? Oh yeah, definitely rotated about a fixed point. Rotated about a fixed point. Center of rotation. The center of rotation. That's this dude up here. We have our pre-image, and our post-image. and we rotated it about a fixed point. This dude right here. That was our center of rotation in our rotation. What was that thing called over here? Line of reflection. Yep. Line of reflection. Just realized I forgot an L there. Line of reflection. All right, I said there was three. There's three pictures here. The third one, we have reflection, rotation, and if you're reading ahead, you know this one's called the translation. Trans meaning across. A translation is a transformation which slides each point of a figure. Slides it. Whoop! Like it's on ice. Whoop! Slides each point of a figure the same distance and in the same direction. In the same distance and in the same direction. So every point in this pre-image moves the same distance and direction to make the post image. Just like that point moved there. This point moves the same amount of distance and in the same direction as the point on the top did. Exactement. The same. Cool. The resulting figure after the transformation is called the, what have we been calling it? We've been calling it the post image. The post image. There's an A in there somewhere. Derp. Post image. It's correct, ladies and gentlemen. That word is image of the OG figure. The OG figure was called the who, the what, the where, the pre image. Why do I not want to put an A? Just not feeling it. Based on the arrow in the diagrams, we're going to label the images and pre-images and post-images. Haha, we already did that. If a point on the pre-image is labeled A, then it's labeled A prime on the image. So let's go up here, do some stuff. So let's got this point A here, and A prime is the same point in the post image. That was the top left corner of the letter F. So this would be A prime in our post image reflection. If this is our point A in our rotation, A prime is that same spot, that top corner of the middle line doody jobby in the F. That's our A prime. We actually drew some points in this translation. Let's just give them some names. There's our A, and there's our A prime. So what would these guys be? Well, maybe we call that point B, and then it's translated to B prime. What do you know about that? Awesome. You guys are doing great. Example number 1. Triangle ABC is translated 1 unit right and 4 units up. Draw the image A prime, B prime, C prime, which is also a triangle. Okay. Here we go. A was at 1, -3. It's supposed to go up 4 units, right 1 unit. I said those backwards, but it doesn't matter. Let's go right 1 unit and up 4 units. 1, 2, 3, 4. What's that guy called? It's called A prime. What are the coordinates of A prime? Well, that is at 2, 1, which makes sense. We went right 1 unit, so we added 1 to the x. And we went 4 units up, so we added 4 to the y. There you go. B is at 3, 0. We got to go right 1 unit and up 4 units. That's called our B prime. And the coordinates of this guy are 4, 4. And C is at 4, negative 2. So we go right 1 unit and up 4 units. C prime. And the coordinates there are 5, 2. And let's make it a real triangle. Doobie-doo-boo-boo. So is that new post-image triangle congruent to the OG? Triangle ABC? Yeah, dude. Yeah, for sure. We didn't change any lengths. We didn't change any angle measures. We used rigid transformation to move it. We used rigid transformation, which preserves length and, wow, having a hard time, angle measure. Preserves length and angle measures. Hopefully your spelling's doing better than mine today. Rough times and spelling high. All right. Which of the following transformations appear to be isometries? What's isometry mean again? It means it's the same basic shape. It didn't change in size. It just moved around some way, some type of way. So A, that looks like a reflection to me about a line of reflection. So, yep. It's the same shape. Didn't change in size. Just changed in orientation. Looking at B, though, that pre-image and post-image, one looks like it got squished. That's not the same shape anymore. Definitely not an isometry. Nope. C, the pre-image and post-image, or just image, I guess is what they're calling it here. I'm calling it post-image, pre and post, man. That's what we're doing. There's that little arrow, dude, which indicates to me that it got, oh, what was that word again? Rotated. About that center point, which we said rotations were isometries, so yep. Cool, little note on those arrows. Mapping describes any transformation with an arrow notation. So we can describe triangle ABC being mapped onto triangle DEF using this notation. Triangle ABC is mapped onto triangle DEF. That means mapped onto, mapped onto. Cool. Y finalmente, like congruence statement, the order of the letters really matters. So, if we're looking at this guy, triangle ABC is mapped onto triangle. Who's in the same spot as A? Just like in congruency D. Who's in the same spot as B? You are correct, my friend, that is E, which only means that this C must be into F. All right. You're going to tell me what triangle PRQ would be mapped onto. Get it, my lovely scholars? You are brilliant forever and always.